Alright, here's a quick video I wanted to make about acceleration and deceleration. Now what I'm going to have this program do is take my mouse position and draw onto a picture box where it thinks it should be going. Now the setup's really simple. All it is a picture box that is 640 by 480 and then a timer that is always set on for every 10 milliseconds. Now I'm going to show you first what the code looks like without acceleration and deceleration. This is a real simple program. First thing up the top here, I define my picture box, or it's the picture image, pic as you will, bitmap 640 by 480. And then the graphics, which is the graphics tool that I'll use to draw a line on there. And then the DrawPoint as a point. Now you don't need to make a Drawing.Point for X and Y. You can actually just use two integers and name one point X and point Y and be good that way. So anyways, on the timer tick, whenever the timer happens every 10 milliseconds, the draw point is defined as the cursor position, which is anywhere from 0, 0 to the length and or height and width of your screen, which in my case is like 1600 by 900, something like that. And then I got to minus the actual position of the form minus the location of the picture box itself relative to the form minus 4. Oops. And then I do the same thing for the height for Y minus 30. Why 4 and 30, you ask? Wow, that's simple, because actually it's not. It took a long time to figure this one out myself, but 4 is the width of this little bar right here, and 30 is the width of the title up here. Now, for some reason, those aren't taken into the calculation of Me.Location. You think it would be, but it's not. But it's actually the physical top corner of your program. So, with that, this gives us the accurate position of the cursor relative to the picture box. So, when I draw a line using the graphics piece here, from using a Pens.Black 00 to the drawing point and putting the pick into the picture box, here's what the program looks like. The line is relative to my mouse. However, here's what I want to show you. As I move my mouse around, just bounce it around everywhere, there's no fluid movement. It just, every 10 milliseconds, it draws a line to where my mouse is. I clear that and do it again, and you can see that as I move my mouse 10 milliseconds, there's just a line being drawn, and that's all there is to that. If I move my mouse really nice and slowly, it draws a really nice curvature there, but bounce it around, it doesn't. Now, other program with acceleration and deceleration. You can see that not a lot's changed here. It's pretty much the same thing, a couple added pieces. Now, the design is the exact same thing. Picture box, timer, always true for 10 milliseconds. And the whole upper portion is still the same, as well as the lower portion. It's just this stuff in here that's changed. Now, first thing that we do is we define 4 variables, and I have the offset of X and Y and the speed of X and Y. Now, what offset is, you can recognize this, it's the exact same equation as the previous program had. Now, the offset is the difference between where my mouse is versus where my drawing point is. Now, drawing point is held globally and not redefined every time the tick happens. So once this tick happens, draw point is a saved variable, and when the tick happens again, it recalls that saved variable, being in a global variable above the tick and not a local variable within the tick. So all that being said, offset is the difference between where my mouse is and where the last drawing point was. So, say I have my mouse in one corner and I move it 100 pixels down, that's an offset of, say, 100. It's just the difference between the two. Now, speed is pretty much that offset times 0.1. And what that means is if I move my mouse 100, it means it's going to take 10 steps to get there for each tick until it gets there. Now, it's not always going to be 10 steps or 10 pixels per step, because the closer you get, the more the offset's going to decrease, and you'll get to like, well, now it's 9 as an offset. Now it's 7, or now it's 4, now it's 3, 2, 1, and you've slowed down getting there because the offset changes more and more because there's less distance between the 2 points. Now to make it go faster, I can put like a 0.3 here, and 0.3 versus a 0.1 will bounce it around pretty quickly. Now this is what it looks like kind of with a nice acceleration to it. It's pretty quickly, and it's not too segmented like the other program was. Put this back down to 0.1. Play that. Oh, nice, slow, beautiful acceleration. Now I'm sure you could even bounce. Oh man, this is almost art. Look at that beautifulness. So you could bounce that down even less, like 0.5. Let's see what that looks like. Oh, real slow. Beautiful. Alright. And then finally, the draw point is just adding the difference here. So DrawPoint.X equals DrawPoint.X plus speed. Now, the speed can even be a negative. If the position of my cursor is actually negative to where the actual draw point is, the speed will become negative, and DrawPoint.X equals DrawPoint.X, and it'll be plus SpeedX, and now that'll actually be a negative. So if DrawPoint.X is 10 and speed is a -1, it'll be 9 now. And then simply I draw a line with a Pens.Black from 0 to 0 to my new draw point, and then put that in the picture box, and I have beautiful acceleration. Oh, that's so lovely. Don't you want to stick that in all your programs? I bet you will. Alright, well, have fun with that.